In this video, we want to express this logarithmic expression as a single log. We have two logs, the log of x plus radical x squared minus 1 and the log of x minus radical x squared minus 1. So we're going to be using some basic algebra and a couple of properties of logs. Let's go through this real quickly here. First, look at the definition of log. Definition states that if you have the log of some number x to a base a, and that's equal to L is your logarithm. That means that x has to equal to the base a taken to the L power. So the logarithm L is nothing more than an exponent. It's an exponent. Also, we want to look at, let's look at an example. Let's say the log of 8 to base 2 is equal to what logarithm? So we're simply asking, is 8 is equal to 2 taken to what power? Well, 2 to the third will give me 8. So that's saying that the log of 8 to base 2 is equal to 3. Now, one of the properties that I have over here states the log of 1 to base a, where a is positive and the base cannot equal to 1, is equal to 0. And the reason for that is because I apply the definition, 1 is equal to this base a taken to the 0 power. Any number to the 0 power other than 0, of course, is 1. Now, that's how this property comes into play here. And the other one we're going to be looking at is the log of a product, this one right here. Log of the product of two numbers to base a equals to the sum of the logs. Log of m to base a plus the log of n to base a. And for the next one, log of a quotient is the difference. Log of the numerator m to base a minus the log of the denominator. So we're going to use two of those properties and some basic algebra. We know that we have the difference and the sum of the same two quantities, in this case a and b. However you want to multiply this comes out to a squared minus b squared. So in this case, we want to express this as a single log. We have a sum right here. So based on the properties we looked at, or one of the properties, if you have the log, the sum of two logs, that can be written as the log of the product. So think of this as your, say, this will be a here, this will be your b here, this will be your a here, this will be your minus b. So the property tells me that if I have a sum of two logs, going back the other way, we know that we have the product of two expressions. That's going to be the sum of the logs rhythms of each expression, sum. So going back the other way here, got a sum of two logs. One is a single log, so this will be the log to base a of this product. X plus square root of x squared minus 1, x minus the square root of x squared minus 1. So what's that going to give us? Well, it's x times x, that's x squared. And then it's minus the product. So it's x squared minus 1 multiplied by itself. Well, that's going to be squared. So that's going to be minus, and then we square this here. I'll put it in parentheses for now, and that'll give me x squared minus 1. So now we have it as a single log here. But it also says to simplify. So let's continue. Got the log to base a. Let's subtract here. I got x squared, and distribute the negative. I get a minus x squared. So x squared minus an x squared gives me 0. And then a minus here gives me a 1. Still got it as a single log, but it's not simplified because the log of 1 to base a, to any base, is always going to be 0. As long as the base is positive and not equal to 1. A to the 0 is 1. So this actually simplifies to the value of 0. So we write it as a single log and then simplify, we get 0. Thanks for watching. We'll see you next time.